In this lesson, we're going to introduce the idea of exponential growth. Exponential equations always look like this, where A represents your initial value. Could be an initial investment, initial debt, initial population, something like that. And B represents your multiplier. All right, so, and there's something about the B value that's going to make your value go up or make your value go down. So it's either exponential growth or exponential decay. So some of the other pieces to this. So that's your basic, but these are all the different things that can happen to it. Your graph, just like your quadratic, where you have your left and right shift, your up and down shift, this H and this K act exactly the same. So your A value is has a couple different things. It's our initial value, which we'll talk about, but it's also your vertical stretch slash compress. Depends on the value. If A is greater than 1, then it's going to be a stretch. If A is less than 1, it's going to be a compress. And it could be a vertical reflection if A is negative. So same types of things that you dealt with the A on your quadratics. So your initial value on this thing is always 0, A. And then that's where your graph starts. Whereas opposed to this, your graph starts at 0, 0, and then you shift left and right, up and down. You're going to start at 0A and then shift left to right, up or down. So your H is a horizontal shift. So left and right. And then your K is a vertical shift. So we're looking at up or down. And your K also is your horizontal asymptote. So every single time you have an exponential growth or decay, your graph's going to level off one direction or another, and it's going to level off at exactly whatever that K value is. So anything on the outside of your equation that is not part of the exponential, those are vertically going to affect your graph, and anything on the inside part of the exponent is going to horizontally affect your graph. So how would a reflection across the y-axis, so you're looking at kind of a horizontal reflection, you're going to have a negative exponent. But we can work around that a little bit. All right, so your graphs for this, and then we'll kind of talk about your B value, your multiplier is never going to be negative. It's only ever going to be positive. It would be a totally different type of thing and a lot more complicated if your B value was negative. So your B is always going to be positive. So if your B is greater than 1, you have yourself an exponential growth because your multiplier is you're taking something and multiplying it over and over and over and over again, and the only way you're going to go up is if the B value is bigger than 1. So if B is bigger than 1, we have exponential growth. So it increases from left to right, and so it looks like this. And this is your 0A, your initial value. And you have a horizontal asymptote at y equals 0. So you have a domain, a range, and our horizontal asymptote is going to be at y equals 0. That can shift depending upon whatever your K is, but just in general, that's where it starts. Your domain is going to go left and right forever. That's what this is talking about. That just basically means you can plug in anything into this multiplier. So your b value can be, your x can be anything. You can take any value to any number up here. All right, so you can take 2 to the 5th, 2 to the fractions, negative exponents, positive exponents, it doesn't matter. So your domain is anything, and your range is very dependent upon what direction your graph is going and where the horizontal asymptote is. So in this particular situation, we got from 0 up. And we don't hit the 0 because it is an asymptote. We get infinitely close to it. And decay is when your multiplier is less than 1. Pretty much between 0 and 1 is one way to think of it, because your b value is not going to be negative. So a decay looks like this. And because your multiplier, so this is again a 0a, and your multiplier is less than 1, so that means every single step you're multiplying by something smaller than 1, which is making it smaller and smaller, so it's decaying, and it's approaching 0, but you're never going to get 0. So like if you're taking half of something, if you keep on taking half of something, you always have something, so you'll never actually hit 0. So your domain, again, is negative infinity to infinity. Your range is, again, from 0 up, even though the graph is going down, but that's a different kind of description. So we're 0 up forever, not including this. And a horizontal asymptote is still y equals 0. So just a quick look of, are these things growth or decay? All you're looking at is if the b value is bigger than 1. So since 7 is bigger than 1, you have growth. And don't go just by the fraction idea. Is 2/3 less than, is 2/3 less than 1? Yes. So you have decay. So here it's because your b value is greater than 1. Here it's because your b value is in between 0 and 1. And now this one, because it's a fraction, kind of makes it feel like we have a decay, but that's not true, because 5/4 is actually bigger than 1. So you have growth, and it is because b is greater than 1. And then just a couple other quick little things on this for your graphs. We're looking at what kind of transformations would be happening on this. So just real quick, if we are comparing this is your left and right shifts, this is your up and down shifts. So what kind of a transformation would you be having? This would be shifting your graph right 2. This would be shifting your graph down 4. And this would be reflecting your graph. So it's a vertical reflection. Okay, and that is just a little bit of an introduction to what the graphs and just what exponentials look like in general.